Alright, so this is an example problem. It's actually not out of the book, but basically you have this beam and then you have this connector from C to D. They're connected to the wall. I drew out the drawing here. They want us to find the reaction forces at A and then the magnitude of the force on the beam at C. So with this, we start out with a free body diagram. I'm just going to draw a simple one just to make sure that it makes sense. So if we do AC, let's do ACB. This is A, C, B. With that, we have AX and AY. So we have stuff going on at the A point. We have CX, CY, and then we have the force at B, which is 4 kilonewtons, so we know that one. And then just quickly, we know stuff about the measurements. 1.5 meters, we go here, 1.5 meters. So here we've got 4 unknowns, right? 4 unknowns and only 3 equations. So this is not good. So I have a frowny face. So we need to know more about this. But when you remember, we talked about the 2 force members. So if we think of CD as a 2 force member, let's just look at the free body diagram for that, CD. So CD, we have, at D we have stuff going on. We have, whatever, dx and dy. And then we have the cx and the cy. But because it's, then we have the cx and the cy. So that's still 4 unknowns with 3 equations. But remember, with the 2 force members, we actually can draw a line between the two, and that'll tell us the directions of the forces. So we're going to have, or what the line of action of those forces are. So force D is going to come up this way. I'm just going to erase those other 2. Just erase that really quick. So this is D. So it's going to look something like this. So the force there and a force there, and they're along that line of action. So we actually do know, so we know the direction of the C vector. So I'm gonna, this eraser is really big. But basically I'm going to erase this CX and CY because we actually do know some stuff about it. Use all these different colors. But so for C, we actually know it's going to be in this direction. And it's 1.5 meters and 1.5 meters. So it's just a 1, 1. And I guess this would be square root of 2 if you wanted to put that there. So we do know the direction of C. So once we know the direction of C, then now we know, we still have our 3 equations, but now we have only 3 unknowns. So we can go forward with that. So let's see, and to finish up our free body diagram, we need to have our X and Y directions. But so we have the sums of the forces in the X direction, some of the forces in the Y directions, and the sum of the moments equal to 0 are 3 equations. With the Y and the X direction, we're going to have 2 unknowns because we have the C and the AX and AY. But if we sum the moments about a point, and I'm going to pick the point that we know the least about, so the sum of the moments about A is equal to 0. And we'll do out of the board as being positive. So about A, we have C that's going to hit it. So 1 over just the Y component of that C times that 1.5 meters. And then if we want to do the X component of C, that's just along here. That doesn't have any perpendicular distance to that line of action, so that's just 0. And then for the 4 kilonewton, let's see, and that one is, if we go from A to C, do our fingers up, so the moment's positive. For the 4 kilonewtons one, we'll go A to the 4 kilonewton force, fingers go down, so it goes into the board, so that one's negative. 4 kilonewtons times 3 meters, what's that perpendicular distance? That equals 0. So now we can get C. So I'm just going to plug that into my calculator. And so we get C equals 11.3 kilonewtons. And we know it's in that 45-degree angle going up. Now let's do the sum of the forces of the X and sum of the forces in the Y direction. So sum of the forces in the X direction equals 0. It's going to equal AX plus that X component of the C. So 1 over the square root of 2 times 11.3 kilonewtons. And then the 4 kilonewton force is all in the Y direction. So we get AX equals negative 11.3 divided by the square root of 2, negative 8 kilonewtons. So what does that negative tell us? Basically all that tells us is that we picked the wrong direction. So AX isn't going to the right, AX is actually to the left. So AX equals 8 kilonewtons to the left. So we just picked the sign wrong whenever we were drawing our free body diagram. It's no big deal. So then we'll do the sum of the forces in the Y direction equals to 0, and that equals AY plus that Y component of C, which is 1 over the square root of 2 times C, minus 4 kilonewtons. And with that, oh, and we know C, I don't know why I didn't write it there, it's at 11.3 kilonewtons. So then we have AY equals, I'm just multiplying it out. And I encourage y'all to follow along with these, like the multiplying stuff out also. So I got a negative 4 kilonewtons. So again, that negative tells me that I guessed wrong, right? So instead of it going up like I drew on the free body diagram, it actually goes down. So AY equals 4 kilonewtons down. So now we have our stuff. We have C, we have AX, and I would rewrite it if I was doing this neater, and AY. And so we're all good.